Have you ever wondered what would happen if gravity just decided to take a day off? Well, on a remote island in the Pacific, that nightmare scenario might actually be happening. Welcome back to 2 a.m. Brain Cell, where we dive deep into the mysteries that make our world stranger than fiction. Picture this. You're walking along a peaceful shoreline when suddenly your feet leave the ground. Not because you jumped, but because the earth itself seems to have forgotten how to hold you down. Objects start floating upward, water flows in impossible directions, and the very laws of physics appear to be having a mental breakdown. This isn't science fiction. This is Anomaly Island, and what happens there challenges everything we thought we knew about gravity. I've spent months investigating reports from this mysterious location, and what I discover will make you question the fundamental forces that govern our universe. Today, we're going to explore the most mind-bending gravitational anomaly on Earth, examine the science behind it, and uncover why some researchers believe this island might hold the key to revolutionary discoveries in physics. The story begins in 1987 when marine biologist Dr. Sarachin made an unexpected discovery during a routine research expedition. She was collecting samples from what appeared to be an ordinary volcanic island when her equipment started behaving in ways that defied explanation. Her depth gauge readings were completely wrong. Compass needles spun wildly, and most disturbing of all, water droplets from her collection bottles began floating upward instead of falling down. Dr. Chin initially thought her instruments were malfunctioning, but when she attempted to radio for assistance, she discovered something even more bizarre. Her radio operator back on the mainland reported that her voice transmission was coming through with a strange Doppler effect, as if she were rapidly moving toward and away from their position, even though she was standing perfectly still. The first documented gravitational event occurred 3 days into her expedition. Dr. Chin was examining tide pools when she noticed the water wasn't behaving normally. Instead of flowing back toward the ocean, pools of seawater were lifting into the air, forming perfect spheres that hovered several feet above the rocky surface. Small fish, seaweed, and even grains of sand joined this impossible display, creating a surreal underwater scene suspended in midair. The phenomenon lasted exactly 17 minutes. Dr. Chin managed to record portions of it on her waterproof camera, though the footage was later dismissed by many scientists as elaborate special effects. However, her detailed field notes and the corroborating testimony of 2 research assistants who witnessed the event sparked the first serious scientific investigation into what would later be called gravitational displacement zones. Over the following decades, researchers have documented over 200 separate incidents on Anomaly Island. These events follow no predictable pattern in terms of timing, but they do share consistent characteristics. The gravitational anomalies typically affect areas between 50 and 300 meters in diameter. They last anywhere from a few minutes to several hours, with the longest recorded event persisting for nearly 6 hours. During these episodes, gravitational pull within the affected zone can decrease by up to 60% of normal Earth gravity, or in rare cases, seem to reverse direction entirely. Objects don't simply become weightless. They experience a complex gravitational field that can pull them in multiple directions simultaneously, creating spiral patterns and orbital motions around invisible gravitational centers. Dr. Michael Rodriguez, a theoretical physicist from MIT, has been studying the island for over 15 years. His team has deployed an extensive network of gravimeters, seismographs, and magnetometers to monitor the area continuously. According to their data, the gravitational anomalies correlate with unusual electromagnetic readings and subtle changes in the local magnetic field. The most compelling theory suggests that Anomaly Island sits atop a unique geological formation containing dense concentrations of exotic matter. This hypothetical substance, which exists only in theoretical physics models, could create localized gravitational fields that interact unpredictably with Earth's normal gravitational pull. When these fields align or interfere with each other, the result is a temporary gravitational chaos witnessed on the island. But exotic matter isn't the only explanation being considered. Some researchers propose that the island volcanic history might have created underground cavities filled with materials that have unusual gravitational properties. Others suggest that tidal forces from the moon and sun, combined with the island's position relative to gravitational anomalies in the ocean floor, might create the perfect conditions for these gravitational disruptions. The most controversial theory comes from quantum physicist Dr. Elena Vasquez, who believes the island might be experiencing quantum gravitational effects on a macroscopic scale. According to her research, quantum fluctuations in space-time, which normally occur only at subatomic levels, might be amplified by unknown mechanisms beneath the island, creating visible gravitational anomalies. What makes this theory particularly intriguing is that it aligns with recent discoveries in quantum mechanics, suggesting that gravity behaves differently at quantum scales. If Dr. Vasquez is correct, Anomaly Island could provide unprecedented insights into the relationship between quantum mechanics and general relativity, potentially revolutionizing our understanding of fundamental physics. The island's effects aren't limited to gravity. Visitors frequently report experiencing time distortion during gravitational events. Digital watches and timing devices often display inconsistent readings, and many people describe feeling as though time is moving slower or faster than normal. Some researchers speculate this might be evidence of gravitational time dilation effects, similar to those predicted by Einstein's theory of relativity, but occurring on a much more dramatic scale. Living organisms also react strangely to the gravitational anomalies. Plants on the island grow in twisted, spiral patterns that seem to defy phototropism, the natural tendency to grow toward light sources. Instead, their growth patterns suggest they're responding to changing gravitational fields. Bird migration routes shift dramatically when passing over the island, with flocks often becoming disoriented and flying in complex spiral patterns before regaining their bearings. Marine life exhibits equally bizarre behavior. Fish swimming near the island during gravitational events have been observed forming three-dimensional schooling patterns, moving in spherical formations rather than the typical horizontal clusters seen elsewhere. Whales and dolphins actively avoid the area during certain times of the year, possibly sensing gravitational changes before they become apparent to human observers. The implications of these discoveries extend far beyond academic curiosity. If researchers can understand and predict the gravitational anomalies on Anomaly Island, it could lead to breakthrough technologies in space exploration, energy generation, and transportation. Imagine spacecraft that could manipulate local gravitational fields to achieve efficient propulsion or power generation systems that harness gravitational energy. However, studying the island presents significant challenges. The unpredictable nature of gravitational events makes it dangerous for researchers to spend extended periods there. Equipment frequently malfunctions or provides inconsistent readings, and the remote location makes emergency evacuations difficult when conditions become hazardous. Despite these obstacles, international scientific organizations have recognized the island's importance. The Global Physics Research Consortium recently approved funding for a permanent research station, complete with advanced monitoring equipment and safety protocols designed specifically for studying gravitational anomalies. Construction is scheduled to begin next year, marking the first dedicated facility for gravitational research outside traditional laboratory settings. Indigenous legends from nearby populated islands include stories about a place where the earth and sky exchange places, where water flows upward like rain in reverse, and where spirits dance on invisible threads connecting heaven and earth. These oral traditions date back centuries, suggesting that gravitational anomalies on the island have been occurring much longer than modern science has been aware of them. Archaeological evidence supports these historical accounts. Ancient stone structures found on the island show construction techniques that seem impossible without some form of gravitational assistance. Massive stone blocks weighing several tons are positioned in ways that would require sophisticated lifting equipment, yet they were clearly built long before such technology existed. Climate scientists have also taken interest in the island because gravitational anomalies appear to influence local weather patterns. During major gravitational events, cloud formations behave unusually, sometimes forming perfect spirals or maintaining geometric shapes that persist much longer than normal meteorological conditions would allow. The island has become a pilgrimage destination for amateur scientists, UFO enthusiasts, and curious travelers seeking to witness gravitational anomalies firsthand. However, local authorities have restricted access due to safety concerns, allowing only approved research teams and guided tours with strict safety protocols. Recent developments suggest that similar gravitational anomalies might exist in other locations around the world, though none as dramatic or well documented as those on Anomaly Island. Reports from remote areas in the Himalayas, the Amazon rainforest, and parts of Antarctica describe phenomena that share characteristics with the island's gravitational events. As we continue to study Anomaly Island, we're confronting fundamental questions about the nature reality itself. This small piece of land in the Pacific Ocean might hold answers to some of the biggest mysteries in physics, or it might reveal that our universe is even stranger and more complex than we ever imagined. The gravitational anomalies on this remarkable island remind us that our planet still harbors secrets that challenge our understanding of natural laws. Every floating drop of water and every reverse gravitational pull brings us closer to discoveries that could reshape science and technology forever. What do you think could be causing these impossible gravitational events? Share your theories in the comments below, and don't forget to subscribe for more explorations into the extraordinary mysteries hidden in our everyday world.